Okay, today we start section 6.2. Main topic here is going to be the law of cosines, not to be confused with law of sines. One uses sines, one uses cosines. All right, gave you a little introductory example of how law of sines works. It's a little more complicated to do that with law of cosines. Okay, we're just going to kind of give you the formulas and run with it. All right, so I can use the law of cosines to solve oblique triangles. The information they give us, I don't really memorize the conditions, but they happen to be side angle side and side side side. Okay, we'll probably save the real life application problems till tomorrow and the Heron's area formula. Okay, so here's just some steps here to help you manage the steps. Feel free to write these over in the margin as well. So success criteria. When we're given two sides and they're going to give us an angle right in between, we're going to have to find a side using the standard form. Okay, so the standard form is titled over here, right? Here's the standard form, here's the alternative form. So we're going to find a side using the standard form. And it has to be a specific side. It's going to be opposite the angle given. We'll get to that once we get into this first example. All right, after that, the second step, you might be tempted to use law of sines, but you shouldn't because it causes some problems with some unknown angles. Make a long story short, you just need to find the angle using the alternative form for law of cosines over here. Do not use LOS, meaning law of sines. Maybe I'll even put in parentheses here. The alternative form I'm talking about is law of cosines. Do not use the law of sines. You might get lucky, but sometimes you'll make critical errors. And it's just easier to take this approach. Okay, when we get side, 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 use the alternative form, okay, again, these three formulas here, to find two angles. Again, a reminder, do not use law of sines. It can cause problems in the process. Pause to copy this down if you need to. All right, so let's look at example one. Use law of cosines to solve the triangle. Again, we've seen that set of directions a few times. That means find all the unknowns. Let's get a little visual aid of what we have. I have a 42-degree angle, so I'll start by kind of drawing that to scale a little bit. So 42 degrees is here. Angle C. Remember, once we place angle C, side C has to be across from it. All right, so then I've got a choice here with 16 and 12. I'm going to put 16 here just because it looks a little bit longer. 12 here. Okay, the angle's across from it. So if I put side B here, angle B is here. And same thing with A. All right, so step one, find a side using the standard form. This law of cosines follows a pattern you'll pick up on after a while. All right, whatever side is opposite the given angle is how you start expressing it. See what I mean? Cosine of C, and look how you start expressing it with side C. Same thing with side B and angle B and A. Okay, so the side that we can find first is going to be C. All right, so I'll just be clear which form we're using. You'll have all of these in front of you when you take your next quiz. So we're using C squared equals A squared plus B squared minus 2AB times cosine of angle C. This is what we're going to use. Okay, and as you can see, we have sides A and B, and I have side angle C. So I have everything I need on the right side. We just got to plug it into the right spot. Okay, so C squared equals the other two sides squared and added together. So 12 squared plus 16 squared minus 2 times the product of those two sides times the cosine of angle C, which is 42 degrees. Okay, so I have all the numbers I need now to figure this out. I'm just going to simplify it a little bit before we go to the calculator, just so I don't have so much to take the square root of. It could cause some mistakes. So here I have some of these calculations already, but 12 squared plus 16 squared. When I add those together, I get 400. Okay, 2 times 12 is 24. 24 times 16, I have that number too. That's 384. Cosine 42. Okay. Basically, in the end, we could keep going and get a number, and then we finally got to take the square root. But, I mean, now I've made it a little more manageable, so I'm going to go ahead and take the square root of both sides to get C, and I'm going to take the square root of this too. All right, so just punch it in like this. Square root 400 minus 384 times cosine of 42 degrees, not radians. 42 degrees, right? So I got to double check to make sure I am in, well, I'll just hit enter while I'm here, but I'm going to double check to make sure I'm still in degrees mode. I am. So that will be my answer, 10.71. They said go to 2 decimals. So C, 10.71. Okay, so that was step 1. We found a side using the standard form. Step 2 says now we're going to find an angle using the alternative form over here. Okay, don't use law of sines, even though it looks like we could. Trust me, we want to avoid something called the ambiguous case. All right, so there was step 1. And I guess I'll try to separate this a little bit too so it doesn't look so confusing. Squeeze in step 2 here maybe. The alternative form, there was step 1. Okay, so let's choose, we got to find A or B, so I'm going to use one of these two. I'll just take this first one. So we're going to set this up as cosine of angle A equals, okay, you just keep looking at that form up there. It says B squared plus C squared. So B squared plus C squared, which you just found is 10.71 squared, minus A squared, which was given as 12. All over, and then it says 2BC on the bottom. So 2 times B times C, 10.71. Okay, so I just plugged everything in, all the sides, because basically they're using all 3 sides, right? On the right side, okay, now we just got to be careful. And I'd probably just close the numerator, close the denominator, rewrite it, and then get our inverse, just so you don't do too much at once. But I suggest doing this. 16 squared plus 10.71 squared minus the 12 squared, or 144. That gives me the numerator of 226.7041. All over the product of 2 times 16, so 32 times 10.71, so 342.72. Now I could divide these, but it's kind of up to you. I mean, we just have to realize when we're looking for an angle, this is when we do the inverse operation in our calculator. So what I'm going to do now to find angle A, it's going to be inverse cosine of this. Or maybe I punch this in and I have a decimal to write down. So inverse cosine of 226.7041 over the 342.72. Okay, so let's take the inverse cosine and we'll get our answer. Second cosine. All right, so I get 48.59 degrees. Takes up a little bit of room because we need to restructure this. Bumped into 3. It's example 3. Okay, so we're only missing one more thing. We're missing angle B. But now that I have 2 angles of the 3, we can just take them away from 180. We don't necessarily need fancy law of cosines. So angle B is just 180 minus angle C minus angle C. A and C, I'm sorry. I said that backwards. All right, so angle B ends up being 89.41 degrees. Okay, let's have you guys try number 2. We'll probably only need to do one of 3 or 4. So I already took up the space on 3, so try to leave some space for 4. You pause and try number 2 right now. Okay. Okay, so we start by finding the side opposite the angle that we're given. So if we're given 39 degrees, we can express this in terms of side A. So it's A squared equals, square the other 2 sides and add them together to get 73, minus 2 times the product of those 2 same sides. Okay, so that's 24. 8 times 3, double it, 48. All right, and then we got to take the square root of that, 5.97. If you had something around 25 to 30, you probably forgot to, or around 30, you probably forgot to take the square root. Take the square root to go from here to here. Okay. All right, and then we can find an angle. It's up to you which one. I chose angle B to get this. All right, and what you might want to do, you can punch all this in the calculator at the same time. Just separate the numerator from the denominator with parentheses like that. And if you do that, you should just punch it in. We'll get this decimal. So then jot down the decimal, second cosine. Inverse cosine of angle B gives me 122.71. Okay, now heads up, if you actually found angle C on this step, you might be off by a few, maybe 1/10 of a degree or something. That's going to happen sometimes, and that's okay. It is accepted as long as you didn't make mistakes. All right. Okay, the only difference for side, side, side is we got to start off using this. So if we're okay now on finding these angles this way, we should be good to go. So side, 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 use the alternative form right now to find the first 2 angles. Then we can subtract them from 180. Don't use the law of sines. Okay, so let's take a look at number 4. Okay, I can choose any of these 3 angles I want to find first, but clearly you can see we're given 3 sides and no angle this time. All right, so just choose one. I think I started with angle B. Actually, I expressed it for B and A. Okay, so let's see if you can set these up. Maybe I should cover it back up so you can try it. See if you can set them up and then solve for angle B and A. I'll give you some feedback on that in just a moment. Okay, and this will be the last problem we'll do. All right, here's a little demonstration too. Once you have it set up, you just close the numerator like I did here. Before you divide by the denominator, this product, just punch it all in at once and you get this decimal, 0.7208. And then we just need to now do, you might want to jot that down as a little checkpoint. So how do I find A? It's second cosine of that decimal. So I just hit second cosine of my answer, and I'm going to get 43.88 degrees for angle A. Okay, and same thing with B. This happens to be negative. That does make a difference. Make sure you have the negative in there. When you hit second cosine, 116.8. Making C 19.32 once we subtract them.